Hello everyone. In this lecture, I'll be dealing about carbon and its compound. This is very important chapter of class 10 chemistry, and this concept is also helpful in higher classes too. Through this lecture, we will get an idea about why in class 10 we have chosen carbon as an important element even though there are more than 100 elements present in periodic table. In this lecture, I'll be dealing about covalent bonds and allotropes of carbon. First, let me explain about some of the basic features of carbon. The symbol used for carbon is C, the atomic number 6, and electronic configuration is written as 2,4. The 4 represents the valence electron. This is the atomic representation where the 2 electrons are present in innermost cell and 4 electrons are present in valence shell or outermost cell. Now, if we see about the reactivity of elements, the reactivity of elements is the tendency to attain a completely filled outer shell, that is, to attain stable noble gas configuration. As we know, the carbon has 4 electrons in its valence shell, so to attain its stable noble gas configuration, carbon has to either accept 4 more electrons or have to lose 4 electrons to attain its stable state. So if 4 electrons is added to the carbon, then carbon will have C4 minus anion, and in carbon if 4 electrons are taken out or loses, then carbon C4 plus cation is formed. But it is seen that in first case, when 4 plus electrons are added in carbon, then it is seen that it will be difficult for the nucleus to hold 10 electrons because the carbon has small size, so this addition of 4 electron is not possible. Also in the second case, when 4 electrons, to remove 4 electrons from the carbon, it is not easy because huge amount of energy is required, because very less distance is present between the nucleus and the electrons. So these electrons and the nucleus are tightly bound. If to elect first electron, it will require more energy for this, and also to release second electron, more energy will required. Likewise, this process will be difficult. So the second process also does not work. So you may be wondering how bond is formed in carbon. So you may be wondering how bonds is formed by the carbon if it neither loses 4 electrons nor accepts 4 more electrons to attain stable noble gas configuration. So the carbon attains its stability by sharing of electrons, that is, with the help of covalent bond. The covalent bond is the bond formed due to the mutual sharing of electrons. As we have so from the concept of covalent bond, now we have seen how mutual sharing of electron occurs. That is, two elements. Here it is seen that 2 elements, 1 electron of A and 1 electron of B, they mutually share with each other to form a stable electronic configuration. So let us take the example of simple molecule. So from the concept of covalent bond, now we have seen how mutual sharing of electrons takes place within the molecule. So let us take the simple example of molecules where the covalent bonding occurred. If we consider the example of hydrogen atom, hydrogen has 1 electron in its valence shell. So to attain stable electronic configuration, that is to have 2 electron in its outermost cell, one hydrogen atom share its electron with another 1 hydrogen atom share its electron with another hydrogen atom to form H2 molecule by mutual sharing of their electrons. So this hydrogen it is also represented by single bond or by electron dot structure. If we see in case of oxygen, the electronic configuration of oxygen is 2 6. Next, if we see the oxygen, for oxygen atom, the oxygen have 2 6 2 and 6 electronic configuration, where 6 electron is present in its outermost cell, outermost valence cell. So oxygen oxygen atoms share its 2 electron with another oxygen atom, forming a double bond. Since 2 electron pair is shared, so double bond is formed. Here the oxygen need to share its 2 electron to form the stable noble gas electronic configuration of neon. And next, if you consider the case of nitrogen atom, nitrogen whose electronic configuration is 2 5 valence electron is present in the nitrogen's outermost cell. So nitrogen, the valence, the 3 electrons share its electron with another nitrogen atom, forming a triple bond. So you may be wondering, such type of 2 or 3 electron pair sharing may occur within the same atom, within the same atom of a molecule, or also within the different atoms in a molecule. Then so in such case, we may take the example of water, where such type of covalent sharing can also occur in the different atoms. In water molecule, we have two hydrogen and 1 oxygen molecule. Oxygen having its 6 valence, oxygen with its 2 6 electronic configuration, where 6 valence electron is present, and hydrogen with its 1 electron. Oxygen share its 2 electron with hydrogen, forming H2O molecule. Next similar example like water, we see in case of ammonia, where the electronic configuration of nitrogen is 2 5, where nitrogen has 5 electron in its valence cell, and hydrogen with its 1 electron. So a bond is formed between nitrogen and hydrogen, when the nitrogen and hydrogen share its electron pair, forming NH3 molecule. Now if we see the covalent bond in case of carbon containing molecule, first we may consider the example of methane molecule. In CH4, the electronic configuration of carbon is 2 4. So the outermost cell of carbon contain 4 electron, that is 4. So hydrogen with its 1 electron share with carbon, and thus form a covalent bond with carbon and hydrogen, resulting into CH4 molecule. Now I'll be discussing about the allotropes of carbon. What is allotropes of carbon? The allotropes of carbon is the element of carbon arranged in different manner with wide varying physical properties. Also, when we study about the allotropes of carbon, we basically remember about two structure, that is graphite and diamond. So from the allotropes of carbon, it is clear that when the atoms of carbon arrange in one form, then graphite is formed, and the same atom when arranged in different manner, then diamond is formed. First, let us consider the structure of graphite. When in graphite, in one carbon, 3 other carbon is attached, and a hexagonal like structure, and in such way a hexagonal like structure is formed one above the other, one above the other. Okay, but the structure of graphite is 2D structure. It is 2D structure. It seems like 3D, but it is 2D structure. It is a layered structure. It is a layered structure, but no strong bonding is seen above the other layer. It is also the graphite is also good conductor of electricity because, as we have seen, that the valency of carbon is 4 and one electron remains because the other 3 position of the carbon is occupied the other. Since this electron is free to move, so it conduct electricity. Diamond is another allotropes of carbon. Here 4 carbon, here 4 carbon is attached to 1 carbon, and here 4 carbon is attached to 1 carbon and forms a network like structure. The structure of diamond is 3D. It is very hard structure because here all the 4 bonds of the carbon are tightly bonded, and it is a bad conductor of electricity. Since there is no free electrons to move. There is another important allotrope of carbon. Which is known as C60 or Fullerene. It is a used football like structure. It's not much important. This structure you will get in higher classes. It is 3D solid network. So this lecture was a small part of chapter 4 of your class 10th NCERT, where I have discussed about the covalent bond, also the covalent bond of the carbon molecules and allotropes of carbon. The remaining part about the unique properties of carbon, its properties like isomerism, catenation, tetracovalency will be discussed further. Thank you.